So first we'll see the introduction to gate level modeling. Okay, what is this gate level modeling? We'll see. Okay, gate level modeling. So GLM. So gate level modeling means suppose uh, so we are developing the code in terms of what? So we are developing the code in terms of gates. Okay, what is this gate level modeling? We are developing the codes. Okay, the codes in terms of gates. Okay, in terms of gates. That is nothing but gate level modeling. Okay, so gate level. Okay, suppose half adder we already seen. No, suppose half adder is there. Okay, half adder. So what is the truth table for half adder? We already seen. So A, B, and inputs, two inputs, and sum and carry. So 0 0 0 1 1 0 and 1 1. Okay, so we know that sum 0 carry 0, sum 1 carry 0, sum 1 carry 0, and sum 0 carry 1. Okay, so how we are implementing this? So that means we are implementing with you got sum equal to a x or b in digital we already seen, no, and carry equal to what, a b. Okay, so we are implementing with so like you are taking the two inputs. Let us take two inputs, a and b, and here these two inputs are given to this XOR gate. Okay, again a and b, so this is given to AND gate. Okay, like this we will represent, that is sum and carry, no. Okay, so mainly we are using like a gate level primitives are. Okay, so we are using primitives. Okay, primitives. So what are these primitives? These are nothing but we are using built-in gates. Okay, these are built-in gates. Okay, so built-in gates, that means these built-in gates are already declared in the library. Okay, already declared in the library. Okay, so already those are nothing but predefined built-in gates. Okay, so here the how the syntax will be there means the syntax for gate level primitive is like this. Suppose mm, so you have gate level primitive, gate level primitive, and gate level instance. Okay, gate level instance, and followed by uh, first output will come, output and input 1 and input 2 up to so on, like this it will get. Okay, this is the syntax for gate level modeling. Is it fine? Do you understood? Hello, understood. Okay, suppose like if you take uh, suppose if you take this gate, suppose like this circuit is there. So this is the output y, and inputs are a b, and this internal variable you consider as w1. Okay, so this is what cin. Okay, so how we are writing, that means so there is an AND gate, no. So let us take the primitive instance name is a1, and this one is a2. Okay, so how to write gate level primitive? So that is and instance name, what is the gate level instance? That is primitive gate level a1, and output, what is the output? w1 comma input a comma b, a comma b. Okay, like this. And this is also AND gate. How to write? That is gate level primitive, that is a2 followed by y, w1 and c1, cin. Okay, cin, like this you need to write. Is it fine? Okay, suppose if it is like XOR gate is there, how to write? So this is my XOR gate, a b and y. Okay, So gate level primitive is XR and gate level instance is X1, X1, Y comma A comma B. Like this you need to write. Okay. And next XNOR is there. So XNOR, how to write XNOR? So this is XNOR Y. This is A B, and you are writing XNOR. So let us take brief gate level instance is X2. X2 A. What is the output? Y comma A comma B. Okay. NAND gate. So NAND gate, how to write? చూడండి అక్కడ సామాన్లో ఉంటాయి సామాన్లు ఇక్కడ ఇటు next here NAND gate is there. Okay, NAND gate. So this is NAND gate A B and output Y. Okay, NAND is let us take N1. So N1 Y comma A comma B, A comma B. Similarly, NOR gate is there. So NOR gate. So this is the NOR gate. Okay, so NOR gate A B and output Y. So NOR, let us take N2, N2. So this is N2 Y A B. Okay, like this we can write. Suppose tri-state buffer is there. How to write? Let us take this is tri-state buffer. Okay, so tri-state buffer. So tri-state buffer means A and Y, and this is enable pin. Okay, so if enable equal to 0, if enable equal to 0, what you will get? So that is y equal. This is active high enable. Okay, active high enable. Enable equal to 0, it will be in high impedance state. And if enable equal to 1, so it is acting as like a buffer. So y equal to what you are getting A. Okay. So how to write? So this is buff if 1 y comma A comma enable, like this. Okay. Suppose tri-state buffer like this is there, enable. So how to write for this one? Buff if 0, buff if 0. Okay, buff if 0, y comma A comma enable, like this. Is it fine? Okay, this is nothing but gate level modeling. Okay, suppose like a gate level modeling. Yeah, so gate level modeling, we are using gate level primitive. No, suppose example like if you write for 2 cross 1 marks, 2 cross 1 marks. Okay, how to write by using gate level modeling? So we already seen the 2 cross 1 marks. No, so 2 cross 1 marks. So two inputs are there. 1 second, 1 minute, 1 minute. లేవా లేకపోతే ఉప్మా చేయండి ఉప్మా ఉందా ఉప్మారా ఉప్మా చేసేయండి yeah, so if it is 2 cross 1 marks, so let us take the inputs A comma B and output is Y, and this is selection line. Okay, so this is 2 cross 1 marks. So how to write the code? So how to implement this? This is a Shannon's equation. No, we already seen in the digital. S bar A plus S and B. No, S bar A and S and B. Okay, how to implement this with the logic equation? That means here, so you are taking so one input. This is A, and selection line is coming through the inverter, no? Okay, this is, let us take, this is selection line. Okay, this is selection line, and let us take this pin is selection underscore n, and here you have the output y1. Okay, and one more input is b, and so directly you are getting selection line, and this is connected to AND gate, and this is connected to the output. So let us take the outputs are y1 and y2. Intermediate wires are there. These are intermediate wires, and output is y. Okay. So like this, you can implement. So that means here first what you need to do, you need to represent, that is module. So this is you can represent the module name as underscore 2 cross 1 mux. Okay. So if it is numbers means the compiler will not take. Okay. Underscore means compiler will take. Okay. And input. What are the inputs? Input a comma b comma yes. Okay. Output y. Yeah. Output. By default, you are not declaring any wire or edge. It will take as wire data type. Okay. So default data type means you are not declaring any data type, means default data type it will take as wire only. Wire. Yeah. Yes. So if it is reg means you need to indicate that that is reg. Okay. So you need to declare the internal variables. What are the internal variables? Wire w1, w2, and let us take s. Okay, w1, w2. That is select underscore n, no? Or you can give select. This is nothing but select underscore n. Okay, and next select underscore n, and so this is not, no. This is let us take the gate level instance is a1, and a2, a3, and a4. Okay, a4. So how to write this? So not of gate level primitive is not gate level instance is a1, and what is the output for this one? What is the input and output? So let us take this is select. Okay, let us take this is select. Okay, select you can take output select underscore n comma select, no. Okay, and for AND gate, a2 output. Hmm. Now we can write a comma select underscore n. Select underscore n. Okay. And next one more AND gate. And A3 and A3. Hmm. Normal select. Yeah. And R of A4. Hmm. Hmm. Y1, Y2. Okay. And N module. So did you? Yeah, ternary operator we can write, but we are discussing gate level modeling now. So, in general, if it is data flow modeling means we can write like that. Okay. Uh, so, so shall I execute this code in Vivado? Or, so you can do, no? You can do. You can try this. Okay. So like this, suppose all gates are there. Suppose if you would consider gate level modeling using all gates. Mm, 1 second. Mm, log programs. DFM. This is all gates by using GLM. Okay. So all gates using GLM. Yeah, I'll show the code. This output you can do, no. Output you can see, or shall I show the output? Hello. No need. Okay. So see here, all gates using GLM. Okay, so you need to elaborate the design and you are getting the output. Okay, so this in the GVim, just I wrote the code. So module all underscore gates underscore GLM input 1 down to 0 in. So I am using a vector. Okay, output y and output yr, y input y NAND, y nor, y xor, y xnor, y not, y buff. Okay, so that means I am using a gate level modeling and y and in 0 in 1 or yr in 0 in 1 NAND y NAND in 0 in 1 nor y nor in 0 in 1. Okay, xor xnor not buff. Like this I can write the gate level model. Is it fine? Okay, so like this you need to write this gate level modeling. So your task is you need to write the code for gate level modeling, gate level modeling, uh, half adder. Okay, half adder using GLM. Okay, task using GLM. First you need to write half adder using GLM. Okay, and already we implemented by using NAND and NOR. No, that also you need to write. And next full adder and also by using NAND and NOR. Full subtractor and by using NAND and NOR. And uh, 2 cross 1 we already completed. 4 is to 1 marks. Okay, 4 cross 1 marks. Okay, and next 4 is to 1 marks using 2 is to 1 marks. Okay, and next 3 is to 8 decoder, 3 is to 8 decoder, and 8 is to 3 decoder, 8 is to 3 decoder, and next 1 bit comparator. 1 bit comparator you write the code for GL. Is it fine? Do you understand? So when can I expect these codes? This weekend? Okay, okay. So this is about GLM. So gate level modeling is nothing but that will be not converted into hardware. So mostly we will not use. Mainly we will use which modeling means data flow modeling. Okay, we are using data flow modeling. Okay. So what is this data flow modeling? We will discuss data flow modeling. So data flow modeling means what? Data flow modeling means we need to use a continuous assignment statement. Okay, continuous assignment. Okay, continuous assignment. That is a keyword we need to use. That is assign. We need to use a keyword called assign. Okay, so this assignment occurs whenever the value of right hand side changes. So when this assignment occurs, when RHS changes, then this assignment occurs. Okay, when this RHS changes, then assignment occurs. Okay, so we need to assign the values to what nets. Okay, assign the values to nets. Okay, values to nets. Okay, and this will execute parallelly. This will execute in parallel. As I told you, like Verilog code is a concurrent language, parallel. Okay, so and this is continuously active. Okay, if you see like syntax is assign, assign, mm, assign statement, assign statement, assign and assign statement. Okay, suppose like if you consider, so by default all the inputs and outputs you need to declare with which data type means we need to declare with net data type only, wide data type. Okay, all the inputs and outputs should be which data type? It should be wire data type only. Okay, Wire means net data type only, no? In net we'll get wire, war, WAN. Okay, is it fine? Okay. Suppose if you consider like wire X, Y, Z, I'll use assign X equal to A and C. Will it work? It will work. And assign Y equal to A or B. Will it work? Okay. Assign Z equal to operators. Yesterday we seen, no? What are these operators? Yeah, yeah. Bitwise operators. Bitwise and bitwise or XOR. Hmm. Suppose if you consider wire XYZ, um, I am considering reg A comma B comma C. Okay, A comma B comma C. I am using assign X equal to A and C. Will it work? Uh, so it will work, no error. It will work. Wire is one bit and reg is also one bit. RHS side, it can be reg data type. It will take, compiler will take. Okay. RHS, you declared with RHS, no. So LHS which data type? Y data type. Okay. Suppose like I will use assign A equal to A or B. Will it work? So yeah, you are getting error. Why? Because LHS, when you are using assign statement, LHS should not be a reg data type. It should be compulsory Y data type. Understood. RHS can be reg data type. Compiler will take. Okay. But LHS cannot be reg data type. It should be compulsory Y data type when you are using assign statement. Always Y. Is it fine? It can be wire or reg. RHS can be, it can be wire or it can be reg. It will take, compiler will take. But LHS should be, suppose if you consider, suppose assign, let us take B equal to B XOR C. This also error, no? You will get error. Okay. LHS should be Y data type. It should not be a reg data type. Is it fine? Okay. Suppose, yeah. So full adder we already seen, no? Full adder. Full adder. Full adder circuit. Sum equal to what? AX or BX or CN. And carry out equal to BCN plus ACN. Okay. So how to draw this full adder? Just this is one XOR gate. Again, you are giving to one more XOR gate, and here A, B, and C. Okay, and mm, so AB, this is CN, and BC, this is connected with AND gate, and AC also. Okay, AC also one more input is coming. AC in, it is coming and it is connected to AND gate. These all are connected to which gate? OR gate, no? Okay, you are getting sum and a carry out. Okay, so by using data flow modeling means what? You are representing in terms of expressions. Okay, you are representing in terms of expressions. So how to write module? My module name is full underscore adder. So I'm using style too. That means I need to declare input a comma b comma c in, output s comma c out, s comma c out, and I'll use a continuous assignment statement. Assign s equal to what? S equal to a xr b xr c in. Okay, and assign c out equal to what? A and b bitwise operator, or b and c in, or c in, or a. Okay, end module. Like this, you need to write. Is it fine? Okay. So like this means previous also. So mux we already seen, no? So by using data flow modeling, how to write? So I'll use a ternary operator. I can use. I'll use assign. Okay, with one statement I can write. Okay, assign y equal to select question mark b. B, 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 B. Why? Because when selection equal to 1, which is connected, B is connected, no. Otherwise, A. Okay. So this is like this you need to write. Okay. So, same thing, you need to write all this by using data flow model. Okay. Suppose this is all gates by using DFM, data flow modeling. This all gates codes using data flow modeling. First I declared with module all gates input 1 down to 0, output is y and y or y and y nor y x or y x nor y not y buffer. So here assign, I need to use a continuous assignment statement. Assign y and equal to what? In 0 and in 1. In 0 or in 1. Not of in 0 and in 1. Not of in 0 and in 1. Like this I need to write, and I can execute this codes. Do you understood this code? Any doubts? Okay. So this is about data flow modeling and gate level modeling and data flow modeling. So anything I want to discuss, tell me. Hmm? Okay. So you can try. You try these codes. So whatever the combinational codes are there, these codes by using GLM gate level modeling and data flow modeling. Okay. So tomorrow we'll start behavioral modeling. Okay. Okay. Yeah. So. Mhm, 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 mhm. Okay.